I see a lot of people overlooking as they go through the deployment phase. They treat it like agile or waterfall architecture. You start off with all of these components and they lock them into place. We're using this version of the model. We're using this and that's not going to change, and we're going to use it, and all of our systems are going to be based off of this system.
Mm-hmm.
By the time that system gets released, every single underlying element is obsolete. Did you have a 3-month program? Yes, it's obsolete. Did you have a year-long program? For sure. It's not even worth connecting to a database at this point. It's not just obsolete, it's so much less efficient that you're robbing yourself of GPU cycles by not taking things off the bat.
Do you think that models should simulate doubt or second guessing as part of responsible inference?
There is this, I'm not going to say self-awareness, but it is self-checks
Mm-hmm.
of layers of doubt, in which an AI system is capable of being able to understand, is what I am saying relevant? Is there a strong data set to support what it is that I am generating? And is what I have said consistent in the context of the conversations that I've been having here?
10,
7, 6,
4, 3, 2.
In this episode of U&AI, we're diving deep into the enterprise AI stack, from modular architecture and regulation to human-centered intelligence, cognitive reliability, and democratizing computational power. AI strategist Thomas Elliott will demonstrate real improvement in the data layer that leads to improved performance and reduced costs for designing your AI system. Thomas brings a unique mix of technical depth and strategic clarity to this conversation. Welcome, Thomas.
Thank you, Chris. Quite the introduction. I'm really glad to be here.
Yeah, thanks for coming on. Today, Thomas is building out systems that support research in cancer, biology, pharma, and other disciplines. Thomas, I saw recently the S&P Global is citing that 46% of all AI projects, whether they're in healthcare, where you're working now, or some of your former lives in telecom and finance, et cetera, that 46% of all AI projects this year are going to be scrapped. According to IDC, the spend on all those AI initiatives is $307 billion. So basically, we're having a Federal Reserve fire sale and $140 billion are being burned up right now.
It's a heck of a humbling position to find ourselves in at the bleeding edge, despite our best efforts to try and put out something that is innovative and useful.
Mm-hmm.
The rush to use these technologies is definitely coming back with some gaps in misunderstanding the tools and misunderstanding of implementation.
Absolutely. So IBM just sent out a survey to a lot of the CISOs and CIOs and CTOs, and half of those respondents that are involved in that $307 billion spend are concerned about data accuracy. And really, this is your specialty. So I'm so excited to learn more from you about how data systems and data enablement has worked in the projects you're working on. If a company's just throwing AI on top of disparate data, then their AI is not working, and it isn't going to work.
That is the pin on the donkey.
That's the tail, and we all have a little blindfold, right? So
yeah.
Let's peek out from underneath that blindfold, right, as we're pinning the tail on this donkey. Part of the why goes all the way back to the 1700s with the introduction of graph theory, right?
Right. You go back to thinking about theories of computation and challenges in computation, and we don't often think about a logistics problem of solving delivery schedules and horses in between cities and communities. But this is very much like that. One of the things that I've definitely been diving into for the past 10 years has been graph theory being put to use in information systems. At Ericsson, it was a very straightforward, this is a network graph, and this is the interconnectedness of routers and endpoints and edges. That works really well when you have very straightforward understanding of the makeup of a network, and it's a great analogy. What's far more challenging is being able to think of information as a knowledge graph,
Right.
and that is being able to think of, Bob and Alice join a meeting. Bob responds to Alice in the context of an email. There are other attendees that are associated with this meeting event. They all have something to say. And then there's a context of what it is that they said that's also interconnected. So these graphs rapidly build themselves out, and it creates for AI a traversable path of being able to understand context.
Right.
And when you can traverse a path and lead a language model through a narrative of interconnectedness and relationships, then the responses that you get from an AI at that point end up being far more accurate, far more in context, far more relevant to what it is that you're trying to get.
Well, you'd mentioned like this correlation between Chatterbox to 11 Labs to Rappy, right? That there are these, that it's the structure. Like when we see AI succeed, they have fundamentally created these graphs, and really getting into the idea of graphing neural networks. Maybe tell us a little bit about graphing neural networks.
Yeah. One of the projects I've become involved in is it's a departure from large language models. One of the weaknesses with a large language model is the stochastic mathematics, the randomness that leads to probabilistic statistics. And that's where, if you don't have really strong coherence and really strong data structures, then that's how we end up with straight up loss of coherence, inability to respond, or inability to respond accurately. And this is where a lot of people end up in that failed state. In GNNs, graph neural networks, that becomes less probabilistic and absolutely more deterministic. So when you traverse a graph, and for the lack of a better example, coming from a telecom background, I'll lean on telecom again. But if you have 3 million entities in your network, and you're trying to figure out from 200,000 alarms that are coming in on a real-time stream, where are my problems and what is my root cause? If I can traverse all paths on my network and look at all of the alarms and look at the relationships of those alarms to all of those layers of a network, my God, what an incredible tool that is in order to be able to understand a root cause analysis.
Yeah. So in a way, whether you're a startup today that has an AI model or multiple models and agentic systems wrapped inside of an AI system that has this wrapper on it and your own technology. And then there's what you're talking about is this, like, we call it like the interaction surface. So the complexity of that, I spent some time in telecom. It was really amazing because a lot of those graphing networks were built out in the telecom space, right, in the 1900s. So that Ericsson experience, I'm sure, is playing huge into this. So whether you're a startup or you are a horse and buggy company delivering molasses, or, you're the largest shipping container system trying to get all the products between China and Korea, right?
Yes.
There's this fundamental principle that you've been working on for a really long time. So talk us through, how do you approach this technological development? So how should we be thinking about tech deployments that support this graph theory?
It's a matter of being able to understand what it is that are the commonalities between the information systems that you have. You have disparate systems with a different almost language between them. If you wanted to have a internal IT system and a CRM system, there's definitely a misunderstanding of what is a customer in between those.
Right.
So beyond just being able to create an ontology that's able to explain the metadata of what it is that you have across your distributed data systems, we're building this semantic layer, this common language
Yes.
of being able to understand what is the data, what is the meaning of the data, what is the meaning of language, and how does that fit when I begin attaching applications to query through a semantic layer with an AI.
Thomas, how should we be thinking about tech deployment in AI today?
I think one of the biggest things that we can pay attention to with the technology stacks that we're selecting is going back to the purpose and the intent and the problem that it's actually solving. What are we actually solving by deploying this technology in this way? One of the things that I think about coming from a data background perspective is the natural transition of how it is that you begin software projects and how they evolve, what they evolve into.
Right.
So if we think of a new service or a new company, starting with Postgres makes a lot of sense. Number one, it has an easy relational structure that every developer is going to be able to understand. Who hasn't gone through CS program and not understood SQL? And as we add users, as we add load, we start beginning to exhaust the capability of that. And, Netflix not Netflix, but Instagram did a really amazing job at being able to grow Postgres infrastructure and dealing with many shards and dealing with distributions. It worked for their use case, might not work for all use cases. And that's when we begin to add replicas and we begin looking at databases that could handle natural distribution. So we get into projects like Cassandra, like Hadoop, where the distribution of data and the parallelization of access to that data becomes part of the DNA of that data system. And then that supports a much steeper growth trajectory because you're increasing the capacity of your system. You're maintaining fairly linearly the responsiveness of your system so that latency to data remains very low. And then the number of concurrent requests also goes through the roof. So if I go back to the principles of what is the problem that we are trying to solve? And let's choose the tools with a great deal of discernment, because at this stage, we've solved a lot of these problems before. AI doesn't really, AI delivers a whole bunch of new problems,
Mm-hmm.
but it also follows very similar resource patterns as to how it is that we should enable that and accelerate the growth of an AI application.
Right. So that distributed system problem, whether it's a deployed AI tech or any other technology, still needs to be highly reliable, right? The output needs to be reliable. There's a massive amount of throughput in these systems. That's consistent with where we were in SaaS. And there needs to be low latency. That's a whole other topic. That's a whole other show about what does real time mean? Talk about a semantic problem. And then the data always has to be available, right? Like this notion of, and repeatable, right? And we'll get into memory, but so how does this feed into microservices? Or do you want to share with us, AI as a distributed service or any of your monolithic architectures?
So when you begin, if you think about this traversal of moving from Postgres to Cassandra to these other distributed systems, it follows similar progression of development principles, and that's moving from monolithic systems to modular systems to distributed systems. And when we think about AI, transformers are definitely in the monolith stage. But what we're seeing in the ecosystem of these LLMs are a modularization of tooling. And that is where we see things like agents, agent workflows, knowledge graphs, which are helping us with persistent memory. One of the challenges with a LLM is that if you want to add new data to it, you have to retrain it, unless it's dipping into a retrieval system. So all of these things modularize different functions that enable AI. And one of the things that I think about are how it is it that we increase the modules around these LLMs to improve accuracy, improve security, improve transparency and explainability.
Fantastic. Yeah, let's take a look at the structure you're talking about. So there's this relationship, right, between the data, the server, and the clients. So can you walk us through how this would work in these different architectures?
So in these diagrams, in the beginning, we see this idea of monolith, where you have a fixed application, it has a database, it has a client-server architecture. Then we begin to add distribution. We start adding replicability of that database. That replica serves for resilience, but also soon it becomes necessary for load balancing. And then we begin to modularize the components, and we may distribute those components across different servers.
Mm-hmm.
And then we get into the idea of microservices. Mm-hmm. And that is where we think less about this module sits on this server. It's more of, it's following the cloud native approaches, the Kubernetes approaches, where we now think of these are all of the services that we need to enable our software ecosystem. Right. And those services might be dependent on services outside of our cloud. We might go to Oath to do authentication. We might go to Datadog for observability and and telemetry. We might go to somebody else for governance. And so we bring in all of these tools and we allow that to be orchestrated. So we have this orchestration layer that is able to connect services with resources and then coordinate attachments to services that exist outside of our immediate ecosystem.
Yeah, so important as we get into this idea of the AI deployment, right, as a modular architecture. So in this traditional model, we have this user interface, we have this business logic, there's a data layer. You and I were talking about how the semantic layer, is the rule set that's connecting data points between reporting modules, integrations, data. But you see it, the way that you visualize it is that it's sitting there, AI deployment as modular architecture. So how does the semantic interact here from client to data service and the model itself?
The semantic layer ends up sitting in between our business logic and our models and data structures.
Mm-hmm.
So that as our business logic or our agents are making calls into either our LLMs or into data sources, or our agents are getting into data sources, that we're going through this semantic layer that's has this meta understanding of what's being retrieved, where it's being retrieved from, how does that translate into the common language across the enterprise.
So how do we tie this back? You've said if your processes are broken, AI is just going to accelerate the chaos. So let's get really pragmatic for a minute and talk about, like, what are the steps in process readiness look like before someone's layering on AI? What are those? What's some guiding principles here on, okay, we're ready to go. We see that we have these different types of systems. What does process readiness look like before layering on AI?
A note to people starting your companies: pay attention to the provenance of data and the metadata of what it is that you are writing in your documentation, in knowledge base articles, in your interactions with customers. More metadata means more meaning and context later, and that means more value can be driven through the life cycle of this data, which extends beyond the life of this product.
Yeah, this should be part of the data room in every purchase of every company, from the Amazon level down to the new unicorn with one employee. Like, in that process of merging or acquiring, the data requirements should be the first thing that an executive team looks at. Can we consume? Doesn't matter what you do. Can we consume this or can we not consume this?
What is, in a lot of column inches were spent on talking about technical debt.
Right.
In the 2015 to 2020, as people were working through microservices. Now it's cognitive debt.
Right. Yeah, absolutely. So how can you share a framework or a checklist, right? So people are bought in, they get the problem, they've been living the problem. Look, anyone who's in tech's been living this problem for the last 25 years, right? So what framework or checklist can companies use to prepare for successful AI adoption?
It's being able to understand the problem that you're solving, understand the pain points that you're removing, and then in the context of that, selecting the appropriate tooling and resources that are going to be brought in to make this to make this problem solved.
And I think that last part about selecting the right tooling, in particular the right AI tooling, the right type of model, the right type of system, uh, is difficult for me to do, right? And it's difficult for most of the people that I talk to about this. Is there any guidance or reference material or anything that you'd recommend on like how should people be thinking? Let's assume that they've listened and that they've communicated that, and then they're developing the plan. How do you determine what type of AI model or AI system should be deployed at that point?
This is the tough part. And that is what I see a lot of people overlooking as they go through the deployment phase, is that they treat it like agile or waterfall architecture. And that you start off with all of these components and they lock them into place. We're using this version of the model. We're using this and that. And that's not going to change. And we're going to use it. And all of our systems are going to be based off of this system.
Mm-hmm.
By the time that system gets released, every single underlying element is obsolete. Did you have a 3-month program? Yes, it's obsolete. Did you have a year-long program? For sure. It's not even worth connecting to a database at this point. It's not just obsolete. It's so much less efficient that you're robbing yourself of GPU cycles by not taking things off the bat.
You talk about how AI is modular, right? It's becoming modular, should be modular. What does that mean in practice, right? Talk us through in this context of, I picked this system or that system, I'm trying to solve this particular problem. How should enterprise be trying to build flexible and sustainable AI?
Your model should be interchangeable at any given point in time. You should be able to slop a new model in. This is a challenge when people tie a lot of importance to an AI ops model that requires continuous training.
Mm-hmm.
I think that one of the challenges that people face is that there's a belief that consistency in response is hugely important because it represents trustworthiness.
Right. Yeah.
And that's not AI thinking.
What should trustworthiness, like this gets into the flexible, sustainable. So you have that level. You talked about how the models being deployed should be transferable. And there's another issue there, which is when OpenAI goes from GPT-3 to GPT-4, if I've built all of my retrieval augmented generation, or I've built my own pre-training inside of my own system, my own library, they didn't take that into consideration when they released 5, right? So who knows? So there's model drift, right? And then there is my training data set now being obsolete because of a change in, can I call them parameters inside of the model? So trustworthiness requires a completely different way of thinking, right?
I think about it this way, and it was agents must have agency. And if we have an AI working on an AI suitable problem, it must have the agency to be able to respond in a way that means it may not be super exact. And if it has to be super exact, then we give it the tools to do retrieval from a database and say, hold on a second, this is a question that requires me to use this tool, which is a database lookup. Let me take this record. I'll replay it back to you. And, it ends up becoming a very expensive script. The biggest outcome that I need to be able to accomplish with being able to orchestrate these services is not just to be able to get the services in the hands of application developers, but to ensure that when they are able to attach their applications to an AI system, that there's a degree of transparency, inspectability, and explainability on how it is that those applications are negotiating with the AI.
Right. Yeah. So explainability, we talk a lot about, we use Donald Rumsfeld's known knowns and unknown unknowns around where I work. And so explainability to us is the brass ring. It is the unknown unknowns, right? It's the fourth zone in this matrix. But so with regulation like the EU AI Act, right? And there's discussions around AI certification here in the US. There's the RAISE Act that's on the governor's desk in the state of New York. How do you see governance influencing architectural decisions?
It's the premise of the EU AI Act. And that is to be able to have an understanding of how was this trained? What data was it trained on? Is the data that it's trained on have property? Can it be identified as someone's property?
Mm-hmm.
Are people being compensated for their property?
Mm-hmm.
And in the process of how is this being trained, when you get into European countries and Canada, there's a significant amount of the law that does cover hate speech.
Right.
Hate speech in those countries is not free speech.
Mm-hmm.
So there is also the discussion of harm. How is the response aligning with language law and what is allowed to be said? So getting into that space it means that AI programs that are being developed in those countries are going to proceed at a much slower rate.
Mm-hmm.
But it means that there's going to be a lot more thought and a lot more effort put into the corpus that those systems are being trained on.
Mm-hmm.
There's a long tail to this, and I don't know how that's going to play out, but I see a potential for a higher degree of quality coming out of those systems.
Yeah, I mean, there's so many components to what you just said, but if we're using just psychological harm, right, as the vector, and that hate speech is a subcategory of either that or societal harm, is another subcategory. Just the governance there alone, if you think about SageMaker or Bedrock, Bedrock has a 1,300-page document on guardrails. I think there's a lot of room to coordinate between legislation, governance, and then companies' internal policies, even that you mentioned earlier. But in a world where, like, if all three of those things are in place, would you be building, like, in a world where that's all certified the way, like I like to say, everybody knows what their FICO score is, but none of us knows what our AI system score is, right? Like there's no system there. But in a world where you have a FICO score on an AI system, how does that affect your build, like how you build? I'm assuming it would offload a tremendous amount of work. Was that an accurate assumption? Like if you already had these systems in place where there was alignment between legislation, governance, and then internal policy for the company that the system's being deployed in?
Yeah, well, I mean, it would mean that all of a lot of the work for establishing guardrails and ensuring alignment with corporate safety and not being able to quantify
Hmm.
that my AI is not going to tell someone to harm themselves in some way.
Right.
That's a huge amount of safety work that I don't have to do.
Right.
If that can be trusted and certified, it's massive.
Yeah, and let's talk about, let's see, maybe a good segue into talking about, so safety's twin is security, right? The Siamese twin of safety is security. So security is often an afterthought. Is that a safe assumption?
When you talk about your feature content, you're talking about your features first. When you get into security, you're talking about non-functional requirements. And a lot of non-functional requirements end up being bolt-on after you've delivered a feature.
So give us, from your 25 years of experience across, these three different industries, with the data background and the semantic layer that you've developed this expertise in, how do your views on something like web portal security or data life cycle hardening, how do those shape the AI systems that you design, and how can people think about this so that it's not slowing them down, but they're starting to realize it has to be addressed early, right?
It's still there, right? If you go to any CISO who's deploying an AI, then their immediate concern is, how does this increase the attack surface on my company?
Mm-hmm.
Yes, there is penetration testing, and there are all kinds of flare attacks and prompt injection that everyone's going to be concerned about and have to figure out some way to solve problems. That's for the cybersecurity people. But AI brings in a new security paradigm, and that is psychological safety.
Mm-hmm.
One of the things that I see, and I've either read papers or heard on the radio, these challenges with AI psychosis.
Right. Yep.
Now becoming, I don't know if the DTSM is captured as a thing yet, but definitely people being led to understand something that might not be real.
Yeah, I was listening to a podcast that was calling this the folie de deux. So it's a French term that means the silliness or the craziness of two, meaning that the chatbot and the human are developing a relationship that becomes tangential, right? And so people who were not previously exhibiting any signs of delusion can quickly develop a delusional way of thinking. And in a lot of cases, share it with family and friends who aren't experts in mathematics or science. And so they don't know how to help that person or even support it or even think that it's delusion in the first place. So it's
or worse, hey, I think you're onto something.
Right. Yeah, which is happening a lot. There's a lot of cases where that's happening.
That sounds
right?
very reasonable.
How should we be holding that AI is an amazing tool that accelerates humanity and accelerates thinking instead of replacing people? So how do you tell us a little bit about this idea of developing cooperative intelligence in an organization or research firm? And, it might be a good time to indicate your project, that you're Compute for Humanity.
Computing for Humanity came out of the death of a friend and family member from cancer. And it was previously called the Cancer Computer. And this program initially started off as just a bunch of computers that we were assembling that had off time that we wanted to do protein folding with. And it grew and it grew and it grew. And the founder, Roy Chartier, has expanded that to Computing for Humanity under the idea that computing and the access to computing for these challenges that are very much related um, to computational problems, such as how it is that molecules map to proteins, and how is it that we can identify what groups of molecules can work to interact with different cancers.
Right.
Cancers, and cancer isn't a homogeneous thing. It can be unique to an individual. So if we look at it from that way, there's, the infinite numbers of permutations and combinations. That is idealistically a computational problem. And he said about working with universities across North America on ensuring that researchers had access to compute environments.
Mm-hmm.
And now that's expanded. We now have the soft launch of My Research Cloud, which is, instead of working with individual learning institutions and expanding their capacity for students, we want to be able to open up a research cloud that's available to people that wish to be able to get access to high performance compute resources.
Amazing. Yeah. So you're talking about providing the inference and compute even on those functions?
Yes. Inference, compute, machine learning, deep learning.
Yeah.
We supply the compute and the tools. They have the applications and the grants.
Fantastic.
And we're trying to connect the two.
When we talk about memory and cognitive function in AI, do you think that models should simulate doubt or second guessing as part of responsible inference?
Yes. And, this is not the first time that we've taught. So I really, really like this, what came out of a couple of our meetups a little while ago. And when it came through your summarization tool, there was an incident of emergence that occurred.
Right.
And it created this idea of cognitive comprehensiveness, which I don't recall that it was something that I said, because it surprised me when I saw it in your meeting notes. But it definitely is that point where the difference between hallucination and emergence is the connection in context of what it is that you're trying to get across.
Wow.
And in this case, we had this emergence event that occurred on the back of our conversation. And it came out of, going back to memory systems and playing into the other discussions that we've had in this chat today of modularization, of features of AI as we go into the future. And to tie it all together, you have these memory systems and persistence of memory, because memory is a tie-in of context, which is meaning of the conversations that I have had with a GPT. And then there is this, I'm not going to say self-awareness, but it is self-checks of layers of doubt. And when I say layers of doubt, it's a system in which an AI system is capable of being able to understand, is what I am saying relevant? Is there a strong data set to support what it is that I am generating? And is what I have said consistent in the context of the conversations that I've been having here? I've been thinking a lot about this. And 2 weeks ago, I was in an amazing position where I had been toiling with this idea of cosine similarity.
Hmm.
And cosine similarity is a means of being able to look at vectors and the angles of vectors in what elements are being included in a response, and using that to generate a risk score.
Right.
Right? So
Yeah.
if you can generate a risk score based on what's generated, then if you have like 0 to 5, then you have something that is highly suspect and probably hallucinated.
Right.
If you have something between 8 and 9,
Mm-hmm.
then it's likely that you have something that's very focused and is explainable through the corpus and it's referencing data points. That next day, a gentleman in a group he calls the Hassam group, and basically what he has been able to do is, although his program only works with OpenAI, he is able to generate a risk score before generation takes place,
Mm-hmm.
and then also use that as a trigger for the AI to say, there is not enough data density or data to support this response. I am going to hallucinate. Let's dip into this retrieval system and gather information from a knowledge graph, and then we'll do another loop and see if I have sufficient information to reply, or I have to say, I don't know.
Mm-hmm. Yeah. The model's lack of an ability to say, or the mechanism, the deterministic mechanism to say, was this a good response?
Yes.
And there's an order of magnitude, just recently, because we have a lot of risk discussions and model response and how to monitor it and how to think about it. But it can be even as simple as telling chatbots that if something falls, so if you think about, you just mentioned a knowledge graph, right? Like you're talking about knowledge graphing to determine a new pathway for the model. That's pretty advanced. But there could be even simpler logic built in at, even the root system prompt, right? That just says, when anyone asks me my opinion about emotional concerns, I say, hey, I'm not an expert, right? Like there's even easier ways to do what you're saying, but somewhere in that continuum is how the knowledge graph works. So I don't know if you want to take a second to think about, or to explain, like, even in this context, how a model can access a knowledge graph sitting on top of its vectorization. So there's this vectorization, there's potentially 2 more layers in there, or another layer, and then knowledge graphing, and it has a relationship to metadata, right?
And, this goes back into your known knowns and known unknowns. And that is, if we know that we don't know something, then yes, we can put that into the system prompt.
Why would we reward an AI model if it is identified an unknown to give us an answer, right? Like, why would we allow that in? Can we just determine that today, Thomas? As of today, your Thomas Elliott declares that globally, any model that is providing an unknown should tag it with an unknown tag. How hard is that, right?
There we go. Problem solved.
Problem solved. We'll call it.
I didn't really comprehend the level of attention that this has in the research community until I saw what happened for the rest of that week. Because it was like, bam, 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 Monday, Tuesday, Wednesday, Thursday. By Wednesday, OpenAI put out their paper on why it is that AI is hallucinating. And then by Friday, Miura from Thinking Machines put out her paper
Mhm.
on preventing hallucinations.
Right.
So it really goes to underscore how incredibly important that thinking about these things is to this community. And it's what we're going to see over the next 6 months to the year is now people are going to, as there's a greater understanding of why, now we're going to see the different approaches to the solutions. And I think it's going to be throw a rock and you're going to find a different solution.
No, that's fantastic.
Very,
Yeah.
a very interesting period as people identify their approaches.
So I love this because it ties into something you've said before, which is, we're using the dumbest version of AI that we'll ever use. So talk to me about what you're excited about over the next 2-3 years. Like, what do you envision that smarter AI system looking like? What can we look forward to?
It's the ability to be able to get these persistent memory systems in at a scale that allows for me to really understand myself.
Hmm.
If I have a cooperative intelligence that's working with me in a data set that a cooperative intelligence can utilize, not necessarily just one intelligence. What an incredible data set of conversations, meetings,
Yeah.
to receive coaching.
Right.
Everything from my speaking, my cadence, the stutters, what are exercises that I can use to help even my voice, add emphasis. All of these things, being able to understand from conversations, what are the things that were said, but also what were the things that were not said that could have been important.
Mhm.
This level of coaching in intimacy and introspection can be incredibly helpful if these systems are safe to do that. If we
Right.
and if we can avoid the delusion gap,
Right.
and get to real development of our personas.
I really want to thank you, Thomas. This has been amazing. What a great experience just learning from you. I'm looking so forward to finding out, what Augmented Intelligence Advisory Group does next, and the Computing for Humanity. These are both major initiatives, and applaud you in the work you're doing. How can our listeners connect with you if they want to talk about any of the things that we've discussed, or to get in connection with Computing for Humanity?
Yeah, computingforhumanity.ca and myresourcecloud.ca are the big websites. And for myself, Your Augmented Life.
That's right. Your Augmented Life.
That's my website, and provides all the different channels to get a hold of me.
Yeah, Your Augmented Life. No cognitive dissonance allowed. Right. Well, to our listeners, thank you so much. If you're building AI systems that you want to last, subscribe to UNAI and share this podcast. Drop us a note on any topics or people that you'd like to hear on this show. Tian Hawkins, Hallie Stern are my hosts, and we discuss emerging technology. Until then, everybody keep exploring.